Hi class, and welcome to our video lesson on 1-3 distance and midpoints, two very big terms in geometry. So distance is just the length from one endpoint to another endpoint. We could easily count the distance of segment AB just by counting with our index finger. We would say it is 1, 2, 3, 4, 5, 6. The length of AB, of segment AB, is 6 units. But one thing that we could use as a formula that would work every time is we could take the right endpoint, which is the number 7, and subtract the left endpoint, which is 1. So if we take 7 minus 1, we get the number 6. We use this formula just because if we had a number like a negative 1,567 is where A is, and B is 5,295, it would be kind of lengthy to count with our index finger 1, 2, 3, 4, 5, all the way from one to the other. So you could just take the right endpoint and subtract the left endpoint, and you're going to get the distance. So the length of AB is 6 units. We can do the same thing here for the next one. If we want to find the length of CD, of segment CD, we would take the right endpoint, 14, and subtract the left endpoint. 14 subtract a negative 7. So when you take 14 minus a minus 7, it's actually 14 plus 7, so the distance of CD is 21 units. We won't be doing as much of that here in this class. We'll do the distance formula many times in this class. So to find the distance on a coordinate grid where we have x coordinates and y coordinates, here's going to be our formula. This is something that you're going to want to memorize. The distance for any segment on a coordinate grid is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. It seems very in-depth, but it's easier than it may appear. All you got to do is take one of these points, E or F, it doesn't matter which one, and call it x1, y1. So I'll call this x-coordinate 1 and y-coordinate 1 for 2, 4. So 5, 8. 5 is the x-coordinate, so I'll call that x2. 8 is the y-coordinate, so I'll call that y2. Now I simply put it into my formula, and I simplify it. So the distance is the square root of x2 minus x1 squared. So x2 is 5 minus x1, 2. So it's 5 minus 2 quantity squared. Plus y2 minus y1, that quantity squared. So y2 is 8, and I'm subtracting 4, that quantity squared, all inside the square root. So that's the distance of that segment. So I continue simplifying. Inside the parentheses, 5 minus 2 is 3, and 3 squared is 9. Plus 8 minus 4 is 4, and 4 squared is 16. So now the distance is the square root of 9 plus 16, which is the same thing as the square root of 25. So my final answer, what is the square root of 25? My distance is 5 units. We'll be doing this distance formula again many times in geometry. So from here to there is 5 units long. Alright, on to the next concept. When we talk about midpoint, midpoint, you know, the definition is kind of almost in the word. It's the middle of 2 points. The midpoint, you can write this down in your notes. It's a point that's halfway between the endpoints. So a couple days ago we talked about betweenness. M is between x and y, the midpoint is. But not only is it between, it's exactly in between. It's saying that if xy is 10 units, that means xm is 5 and my is 5. It is the spot exactly halfway between. And that's what the midpoint is. So if we want to find the midpoint of AB, again, we can kind of just use our index fingers and approximate. If we have to, find the point halfway in the middle, we would go to 2, and we'd go to 6, and we'd go to 3, and we'd go to 5, and voila! 4 is the midpoint. 4 is the point that's in the middle of segment AB. We also have a formula for that works every single time. So the midpoint is equal to the endpoints, so A plus B, and then divided by 2. It's kind of like the average. The midpoint is the spot in the middle. It's the average of 2 endpoints. So for this one, we could say the midpoint is 1 plus 7 divided by 2. So 1 plus 7 is 8, and 8 divided by 2, the midpoint is 4, just as we found out right here. So this helps us because now we could do it on a coordinate grid. So this is the same coordinate grid that we found the distance. We found the distance of this segment. Distance is 5. Now we want to find the coordinate that is right in the middle. So approximating, we want to find the ordered pair of that blue point that I just wrote on there, the spot in the middle. So you see a formula bolded title in your notes, and here's what you're going to write down for that. The formula for the x-coordinate, you'd add up the two endpoints, x1 plus x2 divided by 2, and you'd add up the two y-coordinates, y1 plus y2, and divide that by 2. So your midpoint is an xy ordered pair. It's the average of the x's and the average of the y's. So once again, you're just going to label this x1, y1, x2, y2. If you happen to have 5, 8 as be x1, y1, and point E or 2, 4 be x2, y2, that's just fine as well. You'd get the same answer. Alright, so here's the midpoint. The midpoint is adding up the x's. So it would be 2 plus 5 divided by 2, and adding up the y's. So 4 plus 8 divided by 2. Our midpoint, 2 plus 5 is 7, and 7 divided by 2 is 7 halves, or 3.5. And the midpoint of my y is 4 plus 8, which is 12, and 12 divided by 2 is 6. So there's my midpoint, everybody. It's 3.5, right 3.5, up 6. So this point right here is 3 and 1/2, 6. It's the point right in the middle of E and F. All right. So if we're taking this one, find the coordinates of F, we know the midpoint is 15. So we could think about this logically and say, how do we get from E to the midpoint? Well, we have to go 7 units, isn't that right? 8 plus 7 is 15. So it would make sense then to go from 15 to the other endpoint that we would have to go 7 units. So what is the point F? F is at 22, right? You'd agree with that? You have to go 7 units to the right to get to the midpoint. You have to go 7 units to get to the other endpoint. One way that I also like to explain this, so F is 22. One way that I like to explain this is by using our midpoint formula. The midpoint is equal to one endpoint plus the other endpoint divided by 2. So if we were to substitute in our numbers, M is the midpoint. So 15 goes in for the midpoint. 8 is one endpoint, that's E. So now we could solve this using algebra. So we would multiply both sides by 2 to get rid of the denominator. So 2 times 15 is 30. And that equals 8 plus F. So if we want to find what F equals, we would subtract both left and right sides by 8. And 30 minus 8 is 22. So as you can see, we can get F that way as well. And sometimes I think that's a little bit nicer. I don't know if I'd say nicer, I guess. But when we have something like this, I want to find the point G. This time I know what the midpoint is. E is the midpoint. So this side is congruent. So GE is congruent to EF. So again, you can think about this logically and say, how do I get from this x-coordinate to this x-coordinate? How do I go from 2 to 6? Well, I have to add 4 units. Is that right? So if I have to add 4 units to get from one x to the other x, then I got to subtract 4 units to get from the midpoint to point G. So I'd have to take 2 and subtract 4, and I would get G at a -2. If you take 2 and you have to subtract 4, you'd get a -2. So there's your x-coordinate. Your y-coordinate, how do you get from the midpoint 3 to the endpoint 9? Well, you have to go 6 units to the right. So if you have to go 6 units to the right to get to the other endpoint, you got to go 6 units to the left, so you have to take 3 and subtract 6 units. And then you'd get a -3. So your answer for point G is the ordered pair -2, -3. Once again, I do kind of like to use the midpoint formula for this. Sometimes I think it's a little bit easier. If we take the midpoint formula, the midpoint of the x-coordinate is x1 plus x2 divided by 2. This time I know the midpoint of my x. The midpoint of my x is 2. So I could say 2 equals x1, which is 6, plus the other x-coordinate, I don't know what that other endpoint is, divided by 2. So now solving, I would multiply both sides by 2, and I get 4. That equals 6 plus x2. Subtract 6 from both sides, and my x-coordinate is a -2. And as you can see, I got that right there. I do the exact same thing for my y's. The midpoint of the y-coordinate is y1 plus y2 divided by 2. And if I know what the midpoint is the number 3. Here's my midpoint of the y. So 3 equals one y-coordinate, which is 9. The other y-coordinate I'm trying to find, so 9 plus y2 divided by 2. I get rid of the denominator by multiplying both sides by 2. So 6 equals 9 plus y2. Subtract 9 from both sides, and my y-coordinate is a -3. So my point G, is at -2, -3. So you can do it either way. It doesn't really matter to me. Both of them get you the right answer. -2, -3. One more term that we're going to talk about here is a segment bisector. Once again, the term itself kind of gives you the definition. You guys know what a segment is. A segment is part of a line with two endpoints. So here's a line, one endpoint here, one endpoint here makes it a segment. It's a measurable distance. Bisector. If you've thought of the word, like in science before, if you thought of the word dissect, when you dissect a certain animal or whatever it is, dissect means to cut. Or sect itself means to cut. S-E-C-T means to cut. Bi means the word two. If you think of bicycle, other words that have bi in it, it means two. So bisect means to cut into two pieces, and two congruent pieces would be a better term in geometry. So a segment bisector is anything that cuts a segment into two congruent pieces. So if I were to take this segment I drew and cut it right there, this piece is congruent to this piece. And so I would say this red line right here is a bisector, a segment bisector. So in our diagram right here, it's saying that M is the midpoint of segment AB. Plane N, MD, RM, and M are all bisectors of AB. So we say that they bisect AB. So if AM, let's say AB is 14 units long. M is a bisector, or MD is a bisector, or plane N is a bisector. Basically, it's something that cuts AB in half. So if AB is now cut in half, we could say AM is 7 units and MB is 7 units. It cuts that segment exactly in half. And that's what a bisector is. Lots of terms. We'll practice more problems on distance and midpoints when you get to class tomorrow.